Yeah, 1B1. Monica?
Sir, wait a bit.
Yeah, 1B. B1, huh? From B you read. A already we discussed, right? Before
Yes, sir.
break. So now you will continue from here. B. Read.
Sound and ultrasound are longitudinal waves that consists of compression and rarefactions. Explain what is meant by a wave and describe how a longitudinal wave differs from from a transverse wave. Mhm.
Okay.
Sir, should I say the meaning of wavelength?
Uh, they are they are asking you about explain what is meant by a wave and describe how a longitudinal wave differs from a transverse wave. So here we have two questions, right? First question is what is
Yes.
wave, and second
Mhm.
question is the difference between longitudinal and transverse wave. So you should say both, right? First, you tell us what
Yes.
is called wave. Wave definition, you know,
A,
right?
a peak is a wave consists of a crest and a trough. Basically, a peak is called the crest and the valley is called the trough of a wave. The distance from crest to crest and trough to trough.
Yeah, yeah, is you are saying about wavelength, but they only asked you about wave. What is wave? Not wavelength.
Propagation of disturbances that carries energy from place to place in a regular and an organized way is called a wave.
Yes, so it is the definition of wave. Then second part, we are getting the difference between longitudinal and transverse wave. What is the difference?
In longitudinal wave, the vibration of the wave of the particle is parallel with the direction of energy transferred.
Hmm.
But in transverse wave, the vibration of particle is perpendicular with the direction of energy transferred.
Very good. So you got it now, right? Is it
Yes,
clear?
sir. Yes, sir.
Okay, so Al Farabi,
Yes, sir.
Farabi, yeah, read. Part two, you read.
Figure 1.1 represents a longitudinal wave of frequency 25,000 Hz traveling in while. On figure 1.1, mark 2 points at the center of two different reflections and label each one R. On
Yeah,
figure
rare fraction.
1.1,
Yeah, first you finish one. So mark 2 points at the center of two different rare fractions and label each one R. Parabi, are you in?
yes, sir.
Are you using laptop or your mobile for class?
Mobile.
Okay, so which one is rare fraction? The closer one or the far apart one? Huh? The lines are closer one, that is rarefaction, or lines are far apart, that one is rarefaction. Which one? Farabi, you see the lines here, right?
Ye- Yes, sir.
So look here, lines are sometimes you are getting closer and sometimes it's far apart. So which one is showing you rarefactions? The one line are closer, that part, or the line which are far apart, that part? rarefaction. Parabi? Yeah, Monica, can
Yes,
you
sir.
say which part is rarefaction?
Um, sir, the gap place, is that rarefaction?
The gaps are
Gap
more, right?
places.
And uh,
Yes, sir.
rarefaction is the synonym of expansion. Okay.
Yes, sir.
Okay. You write in your notes that rarefaction is the synonym of expansion. Okay. Have you
Okay,
written
sir.
rarefaction? Rarefaction is another name of what? Another name of expansion, right?
Yes, sir.
So if it is expansion, it will be the far apart, where the lines are far apart, that part, right? Farabi? Hello, Farabi.
Yes, sir.
And they are asking us mark 2 points at the center of the two different rarefactions and label each one R. So which one is the biggest expansion? This one, right? It is the middle, right? Isn't it? Hello, are you seeing the cursor? Are you seeing the cursor? So here in the middle, you label here in the middle. It is R, right? And another one is here R. Is it clear? Why do you have to show? Is it clear? Hello, Monica and Farabi.
Yes, sir.
Yeah, so label this way in your printed worksheet where you'll get it printed. You label this way. It is the middle of one rarefaction, and this is another one, middle. So continue here, Farabi. Continue. Read here on figure 1.1.
Draw a double-headed arrow to indicate a distance that is equal to one wavelength of the wave.
Okay, so wavelength is from crest to crest or trough to trough, right? So this one is rarefaction. Rarefaction is uh, rarefaction is similar to trough, right? And compression is similar to crest. Please write it in your notes. Now you are write it. Rarefaction we are getting that is similar to trough, and compression is similar to crest, right? So this one is similar to crest and this one is similar to trough. So the gap between two consecutive trough or two consecutive crests, that one is known as wavelength, right? Isn't it, Monica?
Yes, sir.
So we are having here the gap between two rarefactions. That one is giving us like from the middle of here. We should draw the line from here till here. Okay. They said draw a double-headed arrow to indicate a distance that is equal to one wavelength of the wave. So it is our double-headed arrow which one is showing us wavelength. Is it clear?
Yes, sir.
So also we are labeling here the wavelength so that it is more clear to us. If you don't write here label as wavelength, then you'll get marks because only they mention to show double-headed arrow. We also labeled it wavelengths. Is more clear to us, right? It is wavelength.
Yes, sir.
Now measure the length of the arrow drawn on figure 1.1 and use it to determine the speed of the wave in oil. So you measure it now. Measure it with your ruler and check what is the value in centimeter. Check it, please. Have you got it?
7.5.
Yeah, so in your ruler, you are getting it 7.5. So right here, 7.5. In between one rarefaction to another rarefaction, you are getting 7.5. Is it 7.5? So big. Check how much is coming. Yeah, Monica, have you taken
Sir,
the
wait.
length properly with your ruler? Have you taken the length with your ruler from the worksheet,
Sir,
Monica?
it comes 3.5.
Yeah. So why you said 7.5?
I just guessed it.
No guessing. You should use your ruler to get it. So 3.5, right? So the size I saw is one, two, three. Yeah, is let me check from the mark scheme. Then I can understand your finding is correct or not. Okay, seven. Yeah, this worksheet on sound. Okay, because it's on screen, it's not possible.
4.
You have to check it on the printed one, right? Then you
Yes,
can get
sir.
it clearly. Otherwise, it is not possible. And use ruler. So what we got here?
Comes 4 or like 3.9, 7 type.
Now is what is shown in the mark scheme. We got here is like 4.7 or 4.9 or 4.8. These three values are accepted.
Oh,
So, so you check it that in your ruler,
4.3 comes the maximum for me.
is it coming 4.3?
Yes, sir.
So after 4, how many lines you are getting? How many millimeters you are getting?
3 to 4 lines.
4 lines only. Okay, let me check. One, two, three. Okay. So you write here 4.4 or 4.3 is your value, right? 4.3 you got or 4.4? Which one exactly? Huh?
Let's count 4.4.
Okay, 4.4. If it is 4.4, it is centimeter, right?
Yes, sir.
It is centimeter. Then 4.4, you write here 4.4 centimeter. Okay. Then they said us to find the speed of sound. This value we should use to find the speed of the wave in oil, right? Isn't it?
Yes, sir.
Now, which formula we'll use to find the speed of this oil wave in oil? Which formula we'll use?
Mm,
We will simply
Speed
use,
is equal to frequency by wavelength times
yes,
wavelength.
yes, yes. So your speed will be product of frequency and wavelength. So frequency is already given. That is 25,000, right?
5,000. Yes, sir.
And it is in hertz, SI unit. So your uh, wavelength you are getting in centimeter. It's better to convert it to SI unit. So if you
Meter.
convert it, what it comes? Divided by 100, right? 0.044, right? What is coming? You got
Yes,
here
sir.
4.4 centimeter, right? So you divide by
Yes,
100, what
sir.
it comes?
Wait a second.
0 point
4.4
divided by
divided by
100,
100. 0.044.
0.044. So what is the answer coming?
25.
Yes,
1.100.
25,000 multiplied
Eh,
0.044. What is coming?
1,100.
1,100
100
meter per second. Okay.
second.
So it is our uh, speed of this wave, that is sound wave, right? Longitudinal wave is most probably sound wave, as we are dealing with sound. This topic is related to sound, right? So this one is coming 1100 meter per second. Uh, in our mark scheme, we got here 0.047. Okay, that is maybe somehow when we took the snap of this diagram, that time it shrinked, right? That's why this length did
Maybe.
not come the way is given in the mark scheme. So your one, whatever you calculated, it is fine. For liquid, it can be also one acceptable value. It is very close to the standard value, that is For this oil, it is 1200. So your one is very close, right? 1100. It's
Yes,
not
sir.
that far. So we can accept it. No problem. Now we have this one. Is it possible to take the snap, the whole thing?
Yes, sir.
Hmm. Just let me take it a little bit up so that okay, no problem. You just draw it from here. Take it
Sir,
from
I
here.
sent it.
Yeah, sent it. So question one, we are done till B, part B.
Mm-hmm.
Now part C. Part C we are doing. Yeah. So look here. What is written C? Yeah. Read it, huh? Please.
A sound wave traveling in a liquid passes into air. Number one, state what happens to the speed of the sound wave as it enters the air. Mm,
Yes. Uh, it was in liquid,
sir,
right?
yes, sir.
Now it's going to air, right?
Yes, sir. Sir, liquid is denser material, right? Denser medium.
Liquid is denser medium, correct. Then what will happen?
Mm,
Yeah, if you get the data you got here in the list, that the more denser the medium, the more the speed, right? Isn't it?
yes, sir.
So
So the speed
this
will
speed will,
increase.
the more denser the medium, we have more speed. So it's going from
Um,
liquid
denser.
to air. You got
The
in,
speed will decrease.
yeah, you got in air, it is around 300. You got in water, it is around 1500. You got in steel, you got 6000, right? So
Yes,
more
sir.
denser the medium, we have more speed of sound, right?
Yes,
So
sir.
it will decrease, right?
Yes, sir.
It's clear now.
Yes, sir.
So you write it here that speed decreases as liquid is more denser than air, or air is less denser than liquid. Any way you can write.
Done, sir.
Yeah, so what you wrote?
Air is less denser than liquid,
Then yes.
and then so the speed of the sound will decrease when it enters the air.
Very good. Very good. Then we have next part, huh? Yeah. Read this part, please.
Some compressions shown have reached the air boundary. The parts of these compressions in the air are not shown on figure 1.2. On figure 1.2, draw the parts of these compressions that are in air. D.
Okay, this one I'm showing you. It is actually not possible for you to
Oh,
figure it out so easily.
yes.
That's why I'm showing it to you. Okay. So one thing you know, that is from liquid to air, the speed decreases, right? Isn't it?
Yes, sir.
So what is our first task? We have to draw the normal. Huh? We have to draw here normal because this one is continuing right here. We take it here. First, you continue it. Huh? This line, this line will continue straight to here, right? Is the surface between air and liquid, right? So till here we continued it. After that, we draw the normal. On this point, we should draw the normal. So after that, if speed is less, what we get? If speed is more, we get bending of any wave uh, away. Hello, are you listening, Monica?
Yes, sir.
If the speed is more, then we get bending is away from the normal. If the speed is less, that time we are getting bending is towards the normal. Like I am giving you a very simple example. In light, when light travels from uh, rarer to denser medium, that time the speed of light is opposite of sound. That is, speed of light is less in glass, right? It's more in air, isn't it?
Yes, sir.
That's why when light is going from air to water, it bends towards the normal. That means where it is speed is less, speed of light is less, there it's bending towards the normal. So for sound, we also maintain the same rule. Where the speed of sound is less, there it will be bending towards the normal. Is it clear?
Yes, sir.
So we are having here towards the normal. We draw it freely just to show us that it is towards the normal. This angle will be bigger and this angle will be smaller, so that we can understand it's towards the normal. Is it clear? Now, after this part is done, what we have to draw? As the speed is as we know from the topic 13, that if speed is less or speed is decreasing, then wavelength is also will be less, isn't it?
Yes, sir. Yes,
So
sir.
wavelength is smaller, that means the gap, we have the gap between two wavefronts, that is giving us wavelength, isn't it? Hello.
Yes, sir.
So the wavelength for this part will be less, that means the lines will draw here The lines you will draw here, those will be nearer than the before, right? Look here, we are drawing. You just can give this way, right? Now you see the way I'm drawing, the gap is less, right?
Yes,
Between
sir.
two wavefronts, the gap is less. That means the wavelength is smaller, right, than before, isn't it?
Mhm. Yes, sir.
You just draw it arbitrarily so that at least you understand it is gap is smaller, right? In between
Mhm.
two wavefronts, we have the gap smaller. Huh? That one is helping us. You do not need to give so many. You just give three maximum lines. Which one will indicate the, yeah, it's clear, right? Clear to you
Mm. Yes,
how
sir.
to draw? Okay.
Mm-hmm.
So complete it, huh? I'm trying to make it more accurate because on screen is not that easy
Start.
to
Mm-hmm.
draw, but I'm trying. Uh, you can do it easily with the ruler, the gap maintaining almost equal, and that one you can do easily. Huh?
Mm-hmm.
So you try it. Huh? The gap, you see, the gap we are having here is less than before, right? And the direction of the wave is now is bending towards the normal. Okay,
Okay, sir.
so this one is done. We have here C1. Okay, the parts we have here. Draw the parts of this compression that are in the air. And part D. What is written in part D? Are you done with drawing?
Yes, sir.
Okay, so this one is the way to draw. We have here, yeah. So can you send it to our group, this diagram, please, so that they can see how to draw it.
Done, sir.
Yeah, thank you so much.
You're
You are really
welcome.
doing great job. You are doing
Thank you.
really great job. So you read this one. Describe in outline how ultrasound is used in cleaning. You got it in your notes, right? How ultrasound is used in cleaning.
Yes, sir.
The first one was cleaning, right?
Yes.
So that
It's
point you
you.
have to, yeah, that point you have to write here. So have you written it or you will write now?
I have it in my notes.
So from your notes you can read it for me.
Mhm.
Read it from your note.
Ultrasound is used to clean street lights, jewelries, and intricate electronic components. Nothing else is written.
Hmm. So you can write it here.
Mhm.
Huh? Done, right? So question one is done, right?
Yes, sir.
And question two is very easy, right?
Yes,
Only
sir.
these two words. They are asking what is meant by ultrasound. Then explain briefly how ultrasound is used in prenatal scanning. This one also is available in your notes, right? So you try it. Question two and question three. These two questions you try. Question two and question three.
Okay. Mhm.
Okay.
Okay, sir.
Thank you so much. Allah Hafiz.
Thank you, sir.